Question 7 is very similar to question 6. This time we're talking about the growth of a particular species of insects. So, we know, we're given this variable x is equal to the population of insects in thousands. Right? What can you tell me about the population of a species of insects, or the population of any species, right? Well, the population is going to be the total number of that species born minus the total number that have died. Now, obviously these two numbers, births and deaths, get very, very big if we talk about, every bug that's ever lived, right? So to deal with something a bit more manageable, we differentiate both of these two sides with respect to t, and we find that the population, the growth in the population, right, is going to be the birth rate minus the death rate. Yeah, and I suppose I should indicate here that b equals to number insects born, thousands, and d equals to number of insects died, also in thousands. Right? And if you think about this formula, that the change in population is equal to the birth rate minus the death rate, this makes sense to us, right? How much has the population of the world changed in, say, a unit of time, say a year? It will be the number of people born in that year minus the number of people who have died in that year, right? And same is true for bugs. So we get this nice model for our differential equation, or for the scenario given, right? The other reason why this is very nice is because it gives us information to do with the birth rate and the death rate. That is, that the rate of death, so dt, is proportional to the number of insects that there are, and that the rate of birth, dB by dt, is proportional to that number squared. So again, we can get two equations here. dd dt is equal to kx, and dB dt is equal to cx squared. And thus dx by dt is equal to cx squared minus kx. We're told that when x equals to 2, the population stabilizes. What does population stable mean? It means that the population is not growing or shrinking, that is dx by dt is going to be 0. Other way of thinking about this, of course, is to say that the birth rate is equal to the death rate, right? That's a stable population. As many people are being born as are dying, so your population will stay the same. So we can substitute this in to find the to change our two variables into just two constants rather, into just one constant. So in this case, 0 is equal to 4, or 2 squared, times c minus 2k, and that gives us k is equal to 2c. So I know dx by dt is going to be cx squared minus 2cx. And I can simplify this. I can factor out. I get dx by dt is equal to cx, x take 2. Now, it doesn't want a c in the equation, it wants an a, but that's okay because they're both just constants. So dx by dt is equal to ax, x take 2, where a equals to c. No worries, right? What does part 2 of this want us to do? So after we've shown that this equation holds, what do we have to do next? So we have dx by dt is equal to ax, x take 2. Well, we're told that x equals to a initially. Find an equation relating a, x, and t. So when time equals to 0, x equals to a, what does that mean? Well, first of all, let's look at this equation up here. This is a simple separable differential equation, so I can differentiate both sides. integrate both sides by going like this. 1 over x take 2 dx is equal to the integral of a dt. So, to integrate this left-hand side, I've got to use partial fractions. So 1 over x take 2 is equal to a over x plus b over x take 2. Or, in other words, 1 is equal to a x take 2 plus b x. And the advantage of partial fractions is that this isn't an equality, this is an identity. So it's true for all values of x. In particular, I can substitute in x equals to 0, and I find that 1 is equal to negative 2a, which means that a equals to negative 1 over 2. Or I can substitute in x equals to 2, which means that 1 is equal to 2b, because this would become 0, and I find that b is equal to positive 1 over 2. So this expression up here becomes the integral of 1 over 2 x take 2 dx minus 1 over 2 1 over x dx, and that's going to be equal to the right hand side, which is at plus some constant. I've used c and k already, so my next favorite constant would be, let's use gamma. Okay, so what do we do from here? Now I can integrate both of these. I get a half ln x take 2 minus a half ln x is equal to at plus gamma. And I can of course simplify this a little bit, multiply everything through by 2 and join these together, so I get on the left hand side 2at plus, it's epsilon now, where epsilon, don't get too worried, I mean these are just constants, I could have used anything to represent this. And then I combine the two logarithms, I get ln x take 2 divided by x. So I'm almost there. I just need to use this initial value when t equals to 0, x equals to a. So that means my value of epsilon is going to be, this disappears, x replaced by a. This is ln a take 2 over a. So my final expression will be ln x take 2 over x is equal to 2at plus ln a take 2 over a. That is my expression relating a, x, and t, and I am finished.